Hello, I'm Mr. Day, and today we're going to talk about slope-intercept form. Alright, this is called slope-intercept form, and each part of it means something else. So we'll start with this back here. Plus b. That b with whatever's in front of it is your y-intercept. What that means is, since this is a slope-intercept form, this equation will give you a line if you graph it. It's called a linear function, right? It'll give you a line. And this number right here will be where it crosses your y-axis. So, if I have a graph here, and then I say, all right, my slope-intercept form here is y equals 2x minus 3. Where this line is going to cross my y-axis right here will always be that last number. So I know this line, without knowing anything else, it is going to cross through at negative 3 on the y-axis. If there's no number there, that means it's 0. So in a slope-intercept form, this back here, this number, so right there, negative 3, will always be your y-intercept. So if I had y equals 2x plus 5, that means my y-intercept is at 5. And it is that simple. Your y-intercept. Intercept is where it goes through the y-axis. Don't overthink it. This number in the back is always it. So if I have y equals 2x, what is my y-intercept then? There's nothing back there. It's 0. You don't put a 0 in an equation because it's understood if it's not there. There you go. That's how you found your y-intercept, and that's what it is in this slope-intercept form. Now, we have the intercept portion of it, your y-intercept. Now, where is the slope portion? That is your m here. This is your slope. All right? This will tell you if it is a negative line or a positive line when you graph it. All right? Think of it as your grades, a negative and a positive. Slope, a positive slope, if you think of your grades, it's going up. It's good. All right? If this was your grades, that would be very bad, and that would be negative, because it is going down, 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 down. Right? Positive and negative slopes. This will also give you your rise over run, and we'll talk about that a little bit later. So that portion is your slope. So slope, intercept. So from this form, I can find where it crosses the y-intercept and how it moves, whether it's negative, positive, and what is its rate of change. And now you just have the x and the y. The x and the y are just your x and y point, a random one that is on the line. All right, so you can see if it is on the line. I could say if x equals 5, I plug it into my formula, and it'll give me my y point out. I can also just make up a random point, and it will tell me if that is a point on a line. So x and y are your actual x and y point that you are looking for. All right, now we're going to actually put something in the slope-intercept form. So this is called your standard form, and you have to switch this to slope-intercept form. All right, you cannot actually solve this and get a number out because you have two variables. What you can do is move it so it looks like this. This is the way you need it if you want to graph it. All right, it'll give you your actual slope and your y-intercept, and it makes it much easier to graph. So what you do is like any other equation. I move what's outside across, and there you go. Now it is in slope-intercept, and now I can graph it because I know where my y-intercept is, which in this case is 6x And then you know what your slope is. So I know it's going, since that is a negative, I know it's going to be a negative line, and it's going to look like that when I graph it. And I know it's going to go through the 6 on the y-intercept. This can also be written as 0, 6. Because that's the point it goes through, but it goes through the 6 on the y-intercept. All right, we're going to do one more, and that'll be it. Now we're going to switch this to slope-intercept form so that we can graph it. The first thing we do is we move away what is outside of the y. We're always trying to get the y alone in this case. So it gives me negative 2y is negative 6 plus 4. Now, the y is not alone, so I have to divide away its coefficient. Now I'm going to do this fast. Negative 2 divided by negative 6 is 3x, and then negative 2 divided by 4 is negative 2. If you have a calculator around, you can do it, or you can just do it in your head. So now, here's my slope-intercept form. My y-intercept is negative 2, or 0, negative 2. So I know my line is going to go through negative 2 on the y-axis. And I know it's going to have a rate of change of 3, which is my slope. Now I'm going to show you how to find the x and y point if you just have an x or a y. All right, so I have my slope-intercept form here, and I say, all right, what is the y point going to be when x equals 3? All right, this is simple enough. You're just substituting that 3 in for the x. So y equals 3. Now I'm substituting that for the x. And now you just simplify. 3 times 3 is 9 minus 2. 9 minus 2 is 7. So y equals 7. So when x is at 3, y is at 7. And now, write that as an xy point, 3, 7. That is the point. So every time that x equals 3, y will equal 7. Right. Now we're going to do it one where we find the x. All right, now let's say my y equals 4. Before we do this, our negative 4 back here is our y-intercept. So I know that this line, when I graph it, is going to go through the point 0, negative 4, or negative 4 on the y-axis. And I know its rate of change, or its slope, is 2. All right? That doesn't really have to do with us solving this problem. You just need to know it, and I figure repetition will help you out. So now I plug in that 4. Now I just solve it like it's a regular two-step equation. Plus 4, plus 4. 8 equals 2x, divide by 2, divide by 2, 4 equals x. So whenever y is 4, x is also going to be 4. All right? Anytime. All right? So that is the answer if I'm looking for the y. All right? I hope this helped out. Good luck.